Hello and welcome. My name is Subhendu and I am a Vedic maths teacher from Nerul, Navi Mumbai, India. I was writing a lesson on subtraction when I felt an invisible force prompting me to do a complex subtraction in a way that I had never heard of or done earlier. After I finished the subtraction using the new method, I sat numb for a few minutes. What, or rather who, compelled me to attempt this new method? Quickly, I solved a number of complex subtractions using this new method, and it was a cakewalk. I nearly jumped with joy. I searched all the known sources and I didn't find this method in use anywhere else. So I decided to share it first with the student community through a web-based seminar as my gift on the occasion of the Teachers' Day of India, celebrated on the 5th September 2009. Teachers' Day in India is celebrated on the birthday of Dr. Radhakrishnan, a noted educationist and the second President of India. And now it's time to share it with you. See, there are two kinds of subtractions in arithmetic: simple and complex. Simple subtraction is when all the numbers in the bottom line, that is subtrahend, are smaller than the ones in the top line, that is menuend. Like this one: 5, 6, 7, 8, 9 minus 4, 5, 6, 7, 8. We love to do these kind of simple subtractions because there are no borrowings and no adjustments, just a simple subtraction. So let's solve it. So 5 minus 4 is 1, 6 minus 5 is 1, 7 minus 6, 1, 8 minus 7, 1, 9 minus 8 is 1. So we can write the answer from left to right if we get simple subtractions, though we are taught to write the answer from right to left in conventional method. In Vedic mathematics, most of the sums are solved from left to right. Now, why do we need to learn answering from left to right? Vedic mathematics is meant for mental calculations using our brain calculator. I call it BCalc. It teaches us how to operate and use our BCalc. We need to input data to our BCalc in a particular fashion. Our BCalc then processes it and outputs the answer to our brain. It also depends upon how trained our BCalc is. If it is well practiced and well trained, it will output the answer completely. Otherwise, it will output part by part. Whatever way it outputs, it's up to us whether to say the answer or to write the answer. When we say from left to right. That's the reason why we need to learn finding the answer from left to right. Complex subtraction is when some of the numbers in the bottom line are bigger than the numbers in the top line, excepting the first ones from the left. Like this one: 4, 5, 6, 7, 8 minus 3, 6, 7, 8, 9. We hate these kind of subtractions, but we do get these kinds of subtractions most of the time. We can't avoid it. So it's better to learn how to handle complex subtractions easily. The best way of handling complex subtractions would be to convert it into simple subtractions. Thank Jagadguru Swami Bharti Krishna Tirtha Maharajaji, an educationist, mathematician and philosopher who rediscovered Vedic mathematics. Because of him, we have come to know about a sutra or formula which is called Nikhilam. With the use of Nikhilam sutra, we can convert a complex subtraction to a simple one. Nikhilam Sutra says all from 9 and the last from 10. It may sound meaningless now, but when I will explain this sutra with an example, you will know how powerful is this sutra. The sutra is talking about two steps and obviously from left to right. First step is all from 9, means all the numbers of the bottom line to be subtracted from 9 except the last one. And the part 2 says the last from 10, means the last number of the bottom line from the left to be deducted from 10. This sutra doesn't talk about the first number from the left. So I did a little modification in the meaning of Nikhilam Sutra and made it a 3-step formula rather than 2 steps like this. First step is -1, that is an additional -1 to the first bottom line number. Second part, as it is all from 9, and the third part is as it is the last from 10. This sutra, this Nikhilam Sutra, applies to complex subtractions only. You see, each subtraction is actually a combination of small individual subtractions. Like in our example, we have 4, 5, 6, 7, 8 minus 3, 6, 7, 8, 9. Though the main sum is this, it is actually a combination of individual subtractions like 4 minus 3, 5 minus 6, 6 minus 7, 7 minus 8 and 8 minus 9 respectively from left to right. In each of these individual subtractions, whenever we get the top number bigger than the bottom number, we consider it as a simple subtraction. And in other cases, if the top number is smaller than the bottom number, we consider this as a complex one. Okay, now let's apply the Nikhilam Sutra to a complex subtraction. Nikhilam Sutra is best explained with subtractions which look like this: 1, 0, 0, 0, 0 minus 5, 6, 7, 8. It's a complex subtraction because except the first individual subtraction from the left, all other individual subtractions are complex. So now we apply the 3-part Nikhilam Sutra to this sum. So the first part is -1. So add an additional -1 to the first bottom line number. So we write -1 here. Now second part of the sutra is all from 9 except the last one. So we discard or strike out all the 3 zeros from the top and we replace it with 9s. And the third part is the last from 10. So we strike out the last 0 on the top line and we write 10 on the top of that. So now our individual subtractions have become 1 minus 1, 9 minus 5, 9 minus 6, 9 minus 7 and 10 minus 8. And wow, all of these are simple subtractions, aren't they? I can stop myself from doing this simple subtraction. Can you? So let's do it. So this is 1 minus 1 is 0, 9 minus 5, 4, 9 minus 6, 3, 9 minus 7, 2 and 10 minus 8, 2. See how Nikhilam Sutra converted a complex subtraction to a simple one. So let's have a look at another one. 4, 0, 0, 0, 0 minus 3, 4, 5, 6, 7. So let's apply the 3-step Nikhilam Sutra on this sum. So we put a -1 below the first bottom line number. Then we strike out the next 3 zeros on the top line and we replace them with 9s. And we replace the last 0 on the top line with a 10. Now the answer is 4 minus 3 minus 1 is 0, 9 minus 4 is 5, 9 minus 5 is 4, 9 minus 6 is 3 and 10 minus 7 is 3. See how simple is this? But there is a twist. Let's understand that twist with the following sum.